Hey, what's up, guys? This is Chung here. So today's daily challenge problem number 714: best time to buy and sell stock with transaction fee. Right. So this is another very classic buy and sell stock problem. The only difference for this one is that each transaction has a fee, right? So again, right, you're given like a array prices, right? Where the price is I is the price of the given stock on the I day, right? And an integer fee representing a transaction fee. So this transaction fee means that in every time when you sell a stock, you need to pay this amount of fee. And our task is to find the maximum profit we can achieve. And we can buy and sell as many times as we want, but we have to pay a transaction fee for each sell, right? And we cannot buy and sell at the same time, and then we must sell before you can buy it again, right? So yeah, I think we'll just dive into the solution directly. So basically, I think I already uploaded two buy and sell stock problem. So the way I solve this problem is that it's always I always define like two DP arrays here. So the first one is the buy, and the second one is the sell, right? So the buy I means that the last transaction we the last transaction we have ever done was buy, right? And what's going to be the max profit, right? This is also max profit. Last was buy, and this one last was sell, right? So I always try to define these two kind of a helper like DP array here, So this one means that no matter, let's say we are at days 10 here, right? I mean, it doesn't really matter how many transactions we have ever done so far. It doesn't really matter. But this one it's telling me that as long as the last transaction, as long as the last action was buy, then this is what it is means, right? And sell means that the last transaction was sell, right? Because on certain day we can do nothing. We don't have to buy or sell, right? And that's the definition of this 2DP array here. So the reason being is that the reason we need this 2DP array is that when we calculate this sell I or buy I, we'll need we'll need the we need the other arrays to help us, because let's say if we want to sell at the I day, right? So the prerequisite is that we have to buy the stock first, right? So that's why when we calculate sell I here, since we need to know, like, we have to buy the stock first. That's why we it's gonna be the buy I minus one, right? And then plus the price. That's gonna be the state transition for sell. And similarly to buy, right? So to buy the stock, right? To buy the stock, I mean, we have to somehow sell the stock first, right? Before we can buy it again. That's why we have sell I minus one, right? And then we decrease the price of the current one. That's as you guys can see, that's why we need this two separate state of either the last transaction was buy or the last transaction was sell. Only then we can be sure we can either do we can sell at the current state, or we can buy at the current state, right? And the final answer will be the sell of n minus one. So this one means that at the last day, right, and the last transaction was sell, right? What's gonna be the max profit? Okay, cool. So that's gonna be the idea here, and then let's start coding here. So we have buy 0, right? Start with this one, sell 0, end, right? So the reason I define this one with 0 is because, you know, the worst case scenario is that we never buy and sell, right? Which means that the worst profit we can ever get is 0. You know, let's say if the price never goes up, let's say the price is like this, 5 4 3 2 1, right? It's always going down. So in this case, basically we'll never buy and sell. That's why the worst case scenario is 0, right? And then to start with the since we have we need to use the I minus 1, right? So which means that we have to initiate the buy and sell for 0, right? Prices, okay, 0, right? And then the sell, actually sell is also 0. So here, so the buy 0 means that, you know, at the days I, if the last transaction was a buy, you know, it means that we have to purchase the first we have to purchase the stock at the first day, which means that, you know, the profit for this if the profit for the first day and the last transaction was buy, it's the price, the negative value of the price, right? And the sell is obviously 0. And then for I in range of 1 to n, right? Then we can do our state transition function here. You know, for each of the buy and sell here, you know, we have two options, right? Like I said, we can either buy at the I state or we don't buy, right? So if we don't buy, what's going to be the value? Of course, it's going to be I by I minus 1, because the remember, so if we don't buy at the current day, so the profit won't change, right? And the last transaction is still a buy, right? And if we decide to buy at the current state, it means that we have to somehow sell the price, right? Before, which means there's going to be sell I minus 1, and then we subtract the price of the current day, right? So similarly, if we want to sell at the I state, right? So first scenario is that we sorry, this state means that, you know, the last transaction was sell, which means that we're not necessarily need to sell at the current I state, right? So if we don't sell at the current I state, it means that, you know, the last transaction is still a sell, right? It's going to be a sell I minus 1, because this one means that even though we don't sell at the current I state, but the definition of the sell, it means that, you know, the last transaction has to be the sell. That's why we use the sell I minus 1, right? If we don't sell at the current I state. And then we do but if we decide to sell at the current day, then we have to buy it beforehand, which is buy I minus 1, and we do a price of I, right? So since we sell at the current day, and for this one, the only difference is that we have to subtract the fees here. And then in the end, we just return the sell minus 1, right? So if I run the code, accept it, right? Yep, cool. So I mean the time complexity and space complexity. So for this one, I mean obviously the time complexity will be the O of n, right? Since we only do a loop once, and space complexity is also O of n, because we have buy and sell to help us calculate the next state, right? But if you watch closely, actually, all we need is that I minus 1 state, right? So which means that we can compress this space complexity from O of n to O of 1. Okay, so and the way it's doing is kind of straightforward. So instead of array, we just define two variables, right? So we just remove that, you know. So now the buy will becomes to this buy, right? And it's going to be the I, right? So similarly for this cell, right? We simply remove those two things, and the buy Actually, so for this one, I think a easier way is that, since we need to use this one to store the previously state, what we can do is we can have like cell two and byte two here actually. So this is a byte two and cell two, right? So in this case, we're making sure, right, that so the byte and cell we use are still from the previous state, right? And then in the end, we can simply assign the byte equals to byte two, right? And then the cell equals to cell two, right? In the end, we simply return the cell. If I run the code, yeah, it should also work, right? Yeah, basically that's a simple technique to compress the time complexity to from decrease the dimension, right, of a of a space complexity. Since all we need is the previously the state, that's why I'm using like this kind of two parameters, right? Another temporary values to calculate the current state, and then I rotate, right? Update the bind cell in the end. Cool. I think that's it for this problem. And okay, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.